Okay, so we're ready to start looking at the dissolution of metals. So as you know, metals don't generally just dissolve when you put them in water. So you take a spoon, you put it in water, even hot water, and it's still a spoon. It doesn't dissolve. And so what we're going to be looking at is the degree to which you have to use other chemical entities to try to get the metal to dissolve. And it turns out some metals do dissolve, and we'll look at one of those first. And so what we're going to do is we're going to look at a series of metals. We're going to look at sodium, magnesium, zinc, and copper. And we'll look at progressively more and more aggressive reagents for trying to get those to dissolve. And then we're going to look at gallium, which is in group 3A or group 13, and try to figure out what dissolves it. And that is a more exploratory portion of our endeavor, in that I don't know what will dissolve it or not dissolve it. I've never actually tried to dissolve gallium. So we're going to start out with looking at sodium. And we're going to look at our reagents are going to be water, hydrochloric acid of different concentrations, and nitric acid of different concentrations, as well as, if those don't work, we'll look at using a base to try to dissolve the metal, which we'll use sodium hydroxide solutions. So we're going to start out by looking at sodium. Sodium is stored in a bottle underneath mineral oil. And the reason for that is it actually reacts with constituents of air, both the oxygen in the air as well as water in the air, as we'll see in a second. So I'm going to take a chunk of sodium. I'll take a couple of chunks of sodium and add it into the water. And it takes a moment for the mineral oil to be released. And then you can see it reacts quite vigorously. It's giving off some smoke, it's bubbling, things are moving around. To test what else is being made, what we're going to do is we're going to add some phenolphthalein in there. And so notice phenolphthalein is an acid-base indicator that turns pink when it's in a basic solution. So we're taking a look at the final solution, which hasn't been stirred just because it's cool looking. And the phenolphthalein we added has turned pink, and that's because one of the products of the reaction was hydroxide ion. So next we're going to take a look at what happens with magnesium. Okay, so we've seen that sodium dissolves in water. And it dissolves not because the sodium itself dissolves, it actually reacts. And the reaction leads to a form of a compound that contains the sodium that is now dissolved. So you can dissolve sodium into water, but it's no longer sodium metal in the neutral sense, neutral state. So next what we're going to do is we're going to look at magnesium, which is to the right of sodium in the periodic table. And we're going to first add it to water, and if it doesn't dissolve in water, what we'll do then, we'll move on and add it to a 1 molar solution of hydrochloric acid. Okay, so what we're going to do is we're going to add some magnesium ribbon into the water and see if it reacts the way sodium did. So just add it in there. And it looks like it's not doing much. Let's zoom in a little bit and see. Okay, it looks to be not reactive. It's not reacting and it's not dissolving. Okay, so let's go ahead and do the same thing, but add magnesium ribbon to hydrochloric acid. There's 1 mole of hydrochloric acid, so it's not weak, but it's not particularly concentrated. So we'll add 4 pieces of ribbon to the 1 mole of hydrochloric acid. And we can see it is reacting. It's bubbling, making a gas. And after some time, we see that the magnesium has dissolved and is now in solution, but again, not as magnesium metal, but as the result of the reaction of magnesium with hydrochloric acid. Let's go ahead again and add some phenolphthalein to see if the solution has turned basic. It's not. And that means something.